Okay, so today the plan, we want to really properly talk about the observer design pattern, especially for the problem that we want to solve using observer pattern. Eventually, we want to move to a general solution called event-driven design. I'll try to give you examples and then give you different solutions in different programming languages as a comparison. But we may not talk about the programs in details. I already made the source code available to you on the lectures page. You can also download them and then play with them. Okay, but at least I'll give you the intuition, like how they work at the runtime. Okay. Unfortunately, in the previous recording, the last 15 minutes was cut off because of noise. But I'm gonna talk about a general problem very quickly. Okay, just as a review. The problem we're trying to solve is we actually got some weather data over here, like a weather station. And we got weather data, we got humidity, we got pressure, and we got temperature. Let's say these are the three measures that we actually care. And what we really want to design are applications that they're actually going to observe or to actually get subscribed to the weather data, so that every time if there's any updates, they can also get updated on their display, like a mobile tablet screen. Okay, so for the purpose of today's lecture, you want to remember the following. Okay, we're gonna talk about three different apps. The first one is called forecast app, and for that one, it only worries about pressure for the measure. So which means when the pressure is reducing, that means it's more likely to rain. Okay, just some physics here. And then for the conditions app, it's just going to keep track of temperature and also humidity. So temperature in Celsius and also humidity in percentages. And also the third one will be called statistics app. And for that one there is going to keep track of the temperature. What's the minimum, what's the maximum, and what's the average over some history period. Okay. So the main message from this slide here, it presents a general problem for this particular design pattern. We got one single weather data, let's say only one single piece. We can generalize the problem later once we see the observer pattern. And then we got three different apps over here. Each one of the apps actually worries about different parts of the measure, right? One worries about pressure, the other one worries about temperature and humidity, and the third one worries about temperature, etc. Okay. Okay, so now the first design, let me go over that very quickly. So this is the design diagram. Let me just go over that. And then for the code, I'll just point to you where you should really pay attention to. Okay. And for the design over here, let's take a look. Well, first of all, notice that the first design is basically one directional. Which means you can see that weather data is the supplier. Whereas all the three apps over here, they are the clients. And you only have a client-supplier relationship from each of the apps into the weather data. So for example, you can see this is one of the client-supplier arrow. And this is the second one, and this is the third one. We don't really have another arrow back, right? You can see that's what I meant by one directional. So now, for each of the apps, let's just go over them very quickly. For the forecast app, you can see we got display over here. So which means maybe every 5 seconds or every 2 seconds, you want to periodically refresh the display on the app. And also what they worry about is the pressure. That's why we keep track of the current pressure and also the last pressure, right? To see if it has been reducing. So this is more likely to rain. For the current condition, so this one, we also got another display feature. You can think about every app, the minimum feature they have to support is called a display, which is to display the latest measure for whatever they care. And also for current conditions, it will be temperature and also for humidity, right? You can see these are the two measures, which is different from just the pressure for the other app. Finally, we have another one called statistics. And for this one, again, we have display and also we got only temperature, that's what we care, right? So these are the three apps. And then for the weather data, on the other hand, you can see, of course, you got all the three measures over here. You got temperature, humidity, and pressure, right? Just try to get used to the terminology that we're gonna keep mentioning throughout the lecture. Okay, and then to really write good contracts, as we learn throughout the course, we define some auxiliary feature over here. Simply call that correct limits, right? To make sure temperature, pressure, and humidity, they're all within the legal limits, right? And then we put that under the class invariant to make sure every time you try to create a weather data objects, it must be within the legal limits. Okay, okay. So hopefully so far there's no question. Okay, that's the first design. And then for the code, I will leave this page clean for you, but you can actually take a look. Okay, one thing I want to highlight, and I'll show you a little bit on the slides. I don't want to spend that much time on the first design, but at least we should know what a drawback is. So for the first design, let's say for example, so this one is similar structure. You can see I also try to show you the one-directional architecture. But now this second page is going to be more about the coding, right? I'm going to show you a little bit code. You can also download the source code for the lectures page to play with the application. Again, you can see for example, forecast over here, okay? What I really want to show you is you can see the attributes, current pressure and loss pressure are the same, just the same as the previous page. What I want to show you is very important, which is here. For the display, notice that the very first step for the display should be to updates. So this means to retrieve the latest value, which means your app is actually going to communicate with the weather data that they are observing and then to retrieve the latest measure. Okay, that's a very important concept. Similarly, for the other two apps, a very similar pattern. Let me highlight it to you. You can see for current conditions over here, also, we also got another display over here, and the display also makes sure the very first step is also to retrieve the latest measure. Okay. And finally, you can see over here for statistics, statistics, also in order to display, the very first step is also to retrieve the latest measure. But now, how exactly do we actually define the updates is really up to individual app, because some app may only have to update their temperature. Some other app might update something else. Okay. And then one more thing to point to you, and then before I show you some code on the slides. You can see for every class over here, right? You can see they all maintain some attribute over here called weather data. You can see weather data over here of type weather data, and also weather data over here of type weather data, and also weather data over here of the correct type, right? That's why we got these three client-supplier relations, right? That's really the essence for the first design. Okay, so far, hopefully there's no question, right? And again, let me just write down what you really want to keep in mind. For the first design, updates, let me say that over here. For every app, they will display periodically. Maybe every 3 seconds, maybe every 5 seconds, okay? And number two, the first step to display is to retrieve. Okay, is to retrieve, that's what I say here, retrieve the latest measure. And this is why we have to maintain some reference over here. You can see weather data, and also weather data, and also weather data. But now here comes one challenge for us. The weather data and also the apps. If you think about it, let me just draw a very quick picture here. If you think about this is the weather data, right? That we are trying to observe by different apps. And also we got maybe app number 1, and also app number 2, and also we got app number 3. Somehow each of the apps is actually observing basically the same weather data, right? It's being shared, just one piece of weather data. However, you want to realize the apps over here and also the weather data here, they might be geographically distributed. Geographically distributed. Which means whenever you want to, for example, for app number 1, to retrieve some data from WD. So this particular link may be quite costly. So for those of you who might have taken the e-commerce course, this will be done by something called remote procedure call. Okay, remote procedure call. which will cost some bandwidth and also some computing resources. So it's not just a simple method call. It will involve some communication over the network because the caller and the callee, they are geographically distributed. Okay, that's something to realize. So now here's a question for you. For design number 1, would it be necessarily efficient at the runtime? Which means, okay, so here's a question. Let me pose the question and then I'll tell you the answer. So the question really tells you why the first design may not be so ideal. Okay, so now the question for you for the first design. Okay, I'll put a question here. Whenever we updates from the app, right? Remember, you only try to update when you want to retrieve, and you want to retrieve whenever you want to display, right? Whenever we update, is it really necessary? Okay, question mark. So this is really the important question for you to ask for judging the first design. Every time, let's say for app number 1, let's say forecast. Every 5 seconds it's trying to display. Every 5 seconds you try to display, it will try to updates, which will involve to remotely call the weather data from the remote end, which might be in a different location. Will every updates be necessarily efficient? Which means would it really be necessary? Maybe sometimes on the weather data end, there's simply no updates. In that case, if you simply try to call the update over here to retrieve the data, you will just retrieve the same value. Then you really have just wasted the computing resources and the bandwidth. Okay, so that's kind of the issue we have over here. I'm going to show you some example to show you exactly what I mean. Okay, but now any questions about the first design? Okay, everybody okay? Okay, let me just go back to the slides. Again, the slides show you the detailed code. I'm not going to go over the code. Okay, I just want to show you something. Okay, for the weather data, the class, you got all the 3 attributes over here. Okay, and then also for each of the app, most importantly, notice that for every app, for example, for forecast, you have to maintain some reference over here for the weather data, right? Just a single reference. Let's make the case simple, just a single reference. And of course, the weather data, as I said, might be geographically distributed. So it will take some bandwidth and computing resources every time you try to call a method or feature on the weather data, right? It's a remote procedure call. That's the most important thing to keep in mind for the first design. And then every time you try to create an object of type forecast, for example, you will have to assign the parameter into the weather data, right? Okay, that's easy. And every time you try to display, you will also, the first step will be to updates. Okay, so this really very similar control structure for every app they're gonna program. But you can think about every app is independent of each other. Okay, let's also for current condition, very similar. Okay, I'm not gonna waste your time. So you can look at that. Okay, and also for statistics, you can see the way the things are highlighted, where the data should be assigned, and also update should be the very first step for displaying. And now we want to see exactly why the first design might cause some unnecessary computing procedure being called, right? That's something we would like to illustrate. Let me try to show you some code very quickly, and then we'll trace that accordingly. Let's say we declare current condition, forecast, and also statistics. Let's say we got 3 instances of the 3 apps. And also we got weather data over here, just single piece of data, just make things simple. And then we got, let's say we create the weather data to be, let's say, I forgot temperature and also humidity and pressure, let's say, for example. The numbers, the precise numbers here are not really important. Just notice whether they get increased or decreased. Okay. Okay, and then you try to create the 3 apps. You can see when I create current conditions over here, I need to pass WD. Okay, I'll show you exactly what that really means. But you can think about, according to our diagram over here, when you actually try to create, for example, forecast, and you pass some WD over here, that means we are building this particular link. Okay, so this is the static architecture. We'll see exactly this can happen at the runtime. We'll show you that. Okay, you just try to create 3 different apps, and then, so now let's say this. I change the measurements, right? WD, you can say change the set of measurements. I don't have it over here in the architecture, but you can think about it just a mutator, like a command. Let's say the temperature, for example, goes from 9 up, increase to 15, and the temperature, humidity go from 75% down to 60%, things like that. And now, as soon as after we have changed, we try to display. And then maybe after 5 seconds, we're just trying to simulate what's going to happen. We do another display. Now, what you want to think about is from line number 11 to line number 12. Is line number 11 necessary? Number 1. And is line number 12 necessary? That's really the question. Okay. And after this, we try to update the measurement again. So now apparently when things are updated, you should really want to make sure all the apps should really retrieve them as soon as they can, so they can always display the up-to-date information. So that's why we got display. So now it really boils down to 11, is it necessary? And also line number 12, is it necessary? Okay, let me show you very quickly some visualization, and then we'll discuss for the first one, and then we can move on to the second one. So this is exactly the code I just talked about. Okay, I also included all the necessary classes for you to trace, right? Let's see very quickly. So now let's say, first of all, we try to create the weather data over here. So this line here, so 9, 75, and 25. So 9, 75, and 25. Okay, that's just the order. So temperature, pressure, and humidity. Again, the numbers themselves are not really important. Just see how the runtime, how things behave. Okay, that's about initializing the weather data. And now let's just try to trace one of them. Let's say we try to do, let's say for current condition, let's say here. I say creates current conditions.make and then WD, right? Now what you want to see is if I go to current conditions over here, right? Current conditions over here, and this is the make I'm calling. And then you can see the weather data over here, we're expecting some parameter. In this case, it's just the WD over here. So this will be WD. Okay, and then you will ensure weather data will be assigned to WD. And the weather data here is simply just the weather data of the current objects, right? So now I'm creating this particular CC. And now I'm saying, so this will boil down into cc.weather data is assigned to WD, basically. Okay, so now think about what's going to happen at the runtime. So that means we're maintaining a link from here to here, one directional link. Okay, it's really important for you to follow so far because the other two apps are done in a very similar way. Okay, let's see very quickly. What about forecast? So now the next line, we'll try to create a forecast, right? FD, which is over here, and we're passing the same WD. So now you can see forecast is actually over here, and then we're calling the make over here. So this will be WD, and then we're doing the same assignments over here. So that means FD.weather data is assigned to WD over here, right? You can see it's the same WD. So now you can see we got aliasing. Both FD and CC, both their weather data fields actually point to the same weather data objects. Okay, and finally, you can very easily you can imagine that we're going to now execute this particular line, and now we got a statistics app, and then to attach that to WD. So now SD.weather data will be also attached to the same objects. And of course, we executed this because statistics and then for the make, they got similar updates that we're going to perform. Okay, so after these 1, 2, and 3 lines, we got the link, only one directional. Okay, hopefully so far no problem. Okay, so now let's say this. Let's say we decided to call this line here to say WD, the set measurement. We want to change the weather data measure to 15, 60, and 30.4. So now this will be, let me use a different color for you. So this will be from 9 to 15, from 75 to 60, right? And also from 25 to 30.4. All you need to know is the measurement actually changed. So now what we need to do is to make sure the apps will actually update their measure as soon as they can. So now let's look at this one here. CC.display, FD.display, and also SD.display, etc. Right? So now if you think about it, when I call CC.display, over here. So now you can see CC is the current conditions over here. And then when you talk about display, what the display will do is it will first call the updates, right? Always the first step. And the updates will try to get access to weather data over here, and also get the weather data to get temperature and humidity, right? That's what we said before. So now what this will do is, from the current condition, we're actually going to follow this link and then try to retrieve both the temperature and also to retrieve the humidity. Okay. However, notice that this particular link over here, okay, this particular link is a remote procedure call. If you're calling that to really update the data, that's not a problem. But if there's really no updates on the data, then when you call that, it's a waste. Okay, so now you'll be very similar for others. Okay, let's just take a quick look. And now if I do also fd.display, okay, I'm not going to trace the code again, but you can see that one will correspond to fd is a forecast. So for the forecast, it's now also going to follow this particular link. And then for the forecast over here, it's actually going to just to get a pressure. Now in that case, it's going to retrieve the latest pressure value. Okay, and finally, if I try to do the next one will be sd.display. So now sd will be statistics. For statistics, it's going to get the temperature. So that means when I follow this particular link, and then I will get the latest temperature. Right? You can see so far all the three links are really necessary. We're not really wasting because there really has been some updates from the previous feature call. Right? So now what we want to see next would be, what about 5 seconds later? Just because we said we call the display periodically on the tablet screen. So let's say if we try to go to these three, again, cc.display, fd.display, and sd.display. So hopefully now you can see it's actually not necessary, because you can see between, okay, let me make it precise over here. From here to here, right, you can see from here to here, there is no change on the measurements. Let me say this is 1, this is 2. You can see line number 1 and line number 2, they are exactly the same line, right? However, line number 1 would not be considered as a waste. That's okay, right? But for line number 2, it would be considered as unnecessary. Okay, so now 2 is unnecessary because no change on measurements. Okay, and then when we actually look at this one here, you can see if we change the measurement again, and then these 3 would be okay. So these would be necessary. Okay, and also this will also be necessary. The first one. And the second one here will be unnecessary. Okay, so this really illustrates the flaw of the first design, because in the runtime, you simply don't know whether the current updates that's being called from each of the apps. You definitely have to make a remote procedure call, but whether that update is really necessary, you don't know, because you only got one directional link over here. You can only rely on the apps themselves to periodically call to retrieve the updates. Okay, let's see over here. We got some question here from John. Okay, what if we call set measurements, but we set the measurement to the same value before? Oh, okay, I see what you mean. Yes, I think what John said was exactly right. So what John was saying is, let's think about some special case, right? You see, currently it's 15 and also 60 and also 30.4. Okay, let's say we call set measurement again, and that one there is simply just going to set 15 and 60 and 30.4. Let's say there's simply no change, right? Just the same value. In that case, if you still try to call updates on each of the app, of course, it will still be considered as a waste. I would say every time, thinking the global picture, every time you try to follow this link over here from the app to the weather data is a remote procedure call. If you're getting just the same data as before, that means you have wasted your resources. Okay. Okay, guys, any questions? That's the first design. And I would say, based on what we learned from the flaw from the first design, it would be quite obvious to actually see how we can move on to the second design, which is the observer design pattern. What we talk about so far is not the observer, but you can think about it as part of it, okay, but not quite. Okay, let me just give you a little bit of high-level summary quickly, okay? So the first design. Okay, so now when apps updates may be unnecessary. If they retrieve the same value, because there's no change on the measurement on the remote end for the subjects. Okay, so now let's think about how we can move this to the second design. And the second design, which is also called the observer pattern, which we'll go over in detail in just a moment. Observer pattern. Okay, so now the idea will be quite easy. We want to say, rather than the apps being aggressive about making the update themselves, we want to say we only try to make the updates when there is an update. But how do we know? The only party that knows about when the update occurred is the weather data themselves, right? So I would say we want to do the following, okay? Let all the apps be passive on updating. Okay, so passive here is really important, okay? Only when there is a change. Okay, let me just make a little bit more space for myself. Okay, let me just put it here. Only when there is a change on the weather data will the weather data invoke updates on the apps. So what do I mean by that? Let me just make it a little bit more visual. In the second design, what we want to do is like this. Okay, we talk about second design. Think about if this is the weather data, WD. Let's say over here we got app number 1. Also we got app number 2. Let's say just got 2 apps, okay? From the first design, we only got this one directional link. But for the second design, in order for weather data to actually be aggressive about whenever there's an update on the weather data side, they will invoke the data, right, to on the apps. So we are basically introducing a backward link like this. So this is a new bit for the second design. Okay, so now imagine this. Every time if there is any updates on the WD, the weather data, what they will do is WD is now going to somehow to notify app number 1 that, oh, there is an update. You should better call your update command or method. In that case, after that, app number 1 will now say, okay, now is the time to make a remote procedure call accordingly. You can see in some way the application are now passive. They only try to call their updates on demand, demanded by the weather data. Okay, similarly, so when there is some updates on the WD, they will also notify app number 2. Similar. Okay, and then they will try to app number 2 will then try to update accordingly. Okay, so you can see there's a sequence over here. Okay, that's only an informal sketch about the idea for observer. Okay, and we're gonna see that. Okay, guys, so far we basically just went over the first design and understand what the flaw is by illustrating at the runtime. Okay, make sure you're okay with that. First design is not that difficult. Okay, after this, and this part over here basically just talk about exactly what the flaw is as we illustrated. And now to really avoid the overhead, the computational overhead from the first design, each application, each app forecast statistics or current condition. We call that they should be subscribed or attached or be registered to the weather data. So they will passively wait for the updates to be on demand, to be demanded. And then the weather data will publish or notify. So these are just terminology people usually use when you talk about the observer design pattern. They will publish and notify the new changes. Okay, so now that means we only try to call updates from the apps when necessary. We're not going to waste the computing resources or the bandwidth. Okay, so that's gonna like a transition from design number 1 to design number 2. Okay, so now we move on to design number 2 here, which is called the observer pattern. Let's see how that would look like. Okay, the main idea will be we're introducing bi-directional link between the so-called subjects, the weather data, and the observer, which are the apps. Okay, so this is, we'll talk about 2 diagrams over here for the observer. We'll talk about, first of all, the general structure for the architecture, and then we apply that to our weather station application. Okay, let's take a quick look to go over with you. Okay, again, as I mentioned before, every design pattern that we talk about right now has to do with polymorphism and dynamic binding. So always think about how exactly these 2 concepts are being applied to the design pattern. Okay, so now for the observer pattern, so this is just in the general sense for you to get some idea. Okay, let's see how we can understand that. We got something called subjects, and on the other end, we also got something called observer, right? You can think about this is the weather data. So this is the app. Okay, and then for clarity, we can also put subjects into one cluster, and also we put observer into another cluster, just for separation of concern, right? And I'll talk about the client-supply relationship between them in just a moment. Let's say for the subjects, right? So now it's really important to see this data structure here. We are saying that every subject is going to maintain a list of observer, right? And then it's called observers. So the observer over here is the static type for every element in the list. And observer is exactly over here, right? So this is the static type. So which means dynamically, what is stored in the list can be any of the observer descending classes. Okay, let me be a little bit more precise over here. Okay, you can think about if we have something of type subjects, right? But note subject can just be effective, for example, right? So subject over here, you simply got observers. Okay, it's OBS for short. Observers is now going to point to maybe a list of elements over here. Okay, every one of them will just be observer, right? Statically. But now dynamically, so we get a polymorphic collection, right? We keep talking about polymorphic collection. It's a very important concept. So now every one of them will just point to some different objects. For example, you can let me just use a different color. Think about observer 1 and also different color, let's say pink, right? So now it could be that this one here is simply pink. This one is pink. And this one is orange, and this one is orange, right? You can see dynamically they might be of different types as long as they are the descendants of the observer. Okay, and then we got another method of feature over here called notified. Okay, we'll talk about exactly how to define the notify in just a moment. And then we'll try to say this notify simply notify and updates maybe a change on temperature or a change on maybe humidity. Doesn't matter. Okay, to all the observers. And then you'll make sure, so this is using universal quantification to say when you go across all the observer, every one of them is actually up to date. Okay, and you will see more concrete code in just a moment. So now we'll just talk about general structure. You want to make sure whenever there is any, think about whenever there's any updates on the subjects, right? The subject might also store some, for example, temperature and also humidity and also pressure, right? Whenever there's any updates on any of these, what the subject will do is going to go over this particular list element one by one. And then for every one of them, is going to let them call the updates feature on themselves. So there's on demand, right? That's what we meant before. So one by one, okay? Okay, let's take a look at the observer side. How should they look like? And then once we finish the general discussion, we can go on to the particular instantiation of the observer pattern on the weather station. For the observer over here, let's see. You can see we got some updates command, right? And notice that the update here is deferred. And notice that the observer is also deferred, like abstract, which means at the general observer level, we simply don't know how to update, right? Because later on, for example, observer 1 could be maybe forecast. In which case, the updates will have to update just the pressure, right? And also maybe we got another one, let's say statistics. Statistics is just another observer. In that case, they will also have to implement the updates. In that case, they will only do maybe temperature, right? Depends. So you can see every concrete observer will have to be updated differently. That's why at the general level, we simply keep it deferred. And then also similarly, what does it really mean for the observer to be up to date, right? Let's say in the case of, let's say forecast, maybe it will be up to date when the pressure is the up to date value. And then for statistics, it will be up to date if the temperature is up to date. So this part here is also deferred because at the general level, we simply don't know how it should be implemented. Okay, finally, I want to talk about one more thing, the client-supplier relationship over here. So now look at this arrow over here. Okay, I'll make it bigger. This arrow over here, which means we go from subject into observer. Okay, and this one here is called attached and also detached. I'll just show you one of them. The reason we are having this is because in the subject side, okay, I'll just put it here. We actually got one command called attach. And the attach is going to have observer, let's say new observer, and observer. Like that. And also detach will have a similar signature. Attach simply means I want to add a new observer for the current subject. For example, let's say if this is subject sub. If I say sub dot attach, for example, and then I'll just show you symbolically, right? So let's say we try to add just one observer over here. Let's say the blue one. So what this will do is it's going to simply add a new element to the list for this particular subject. And then we're going to let this particular observer to be added to the list, right? That's basically what it means. And similarly, if you want to detach a particular observer so that later notification from the subject will not be seen by that particular detached observer. Okay, so attach and detach, like insertion and removal. And in the terminology for observer design pattern, they usually talk about attach and detach. Okay, okay, guys, any question about this particular observer pattern in general? Okay, we have the chance to revisit that one more time when we instantiate a pattern into weather station. But before I do that, any question? Okay, I hope so far it's still straightforward. Okay. Let's now go on to the next one, okay? What we want to do is to really take a look. It's still the observer pattern, but now we are being more concrete about our particular implementation, okay? Our particular application, okay? Basically, everything is similar. Let me highlight to you the similar stuff and then tell you what are the extension for the instantiation, right? So now we are really talking about the instantiation for weather station, right? So now let me use green to tell you which part are what we have seen before. First of all, you can see we got observer, right? This is the same as before, and we got observer. And also we got attach and detach. We haven't seen exactly how to implement that. We'll see in just a moment. And also we got also notify, and also we got this particular contract over here, right? To make sure every observer after the notify should be up to date. And also for the observer, you have the defer updates and also up to date with the subject, right? This is the same as before, just the same as before, okay? Let's see what's new. What's new over here is, I'm gonna use pink. So now in the weather data class, we're gonna let it inherit from subjects. So now our weather data is now a subject, right? So now that means weather data is going to have observers of type list of observer. And specifically, what can the observer be at a runtime? So now in this case, it could be forecast, it could be current condition, it can also be statistics, right? Because they are all descending classes of observer, okay? That's something you want to immediately see from the diagram. And then For weather data, not surprisingly, you also got temperature, humidity, and pressure, right? And also correct limits. So this part here is similar to what we saw in the first design, right? That's good stuff. So that's why we can adapt them to the second design. And one final thing, very important, okay? You can see right now for let me just highlight it to you. For the forecast, for the current condition, and also for statistics. For each one of them, remember we still got the weather data link over here, right? One from forecast to weather data. One from current conditions also to weather data. Another one from statistics also to weather data, right? Just the way I drew it, I just try to draw it in a one single arrow. But that's what really it means. Okay. So now you can really see the bidirectional link. You can see from subjects to observer, it goes like this, right? And also from forecast, one of the apps, to the weather data, it goes like this. It's really bidirectional. We're gonna see exactly how we can build this bidirectional link. How about this? Let me show you very quickly. Now that we are talking about this. So the bidirectional link is the most important part for the observer pattern. Let's see. Again, let me just show you, maybe I'll put it here. So it's bidirectional connection between subjects and observers. Okay, subjects and also observers. So now I'm just going to show you some idea to gain some intuition, and then we'll see how to do that programmatically. So now what we have is this. Let's say this is our subjects over here. Let's say sub over here, subjects. And the subject, you know what? Let me just say weather data. So that may be a little bit more relevant to your application. Let's say this is weather data. Okay, let's say weather data. Okay, and then remember weather data actually got temperature, humidity, and also pressure. Okay, so these are standard. And also we got another one called observers. And then that one there is going to be a list of observer. Initially just empty. Okay, let's say now what we want to do is, let me just show you one. Let's say we create a new app. Let's say current conditions. Okay, so now this is current conditions. Current conditions app. In that case, we only worry about the temperature. Okay, if I remember correctly. So temperature is the only thing that we worry about. Okay, every time we want to keep things up to date, we should really query about what's the latest value for temperature. And then for the current condition, you also got another link called weather data, WD, right? So now this is the important thing. Every time when you try to create a new app or observer, you should really establish the bidirectional link. What we learned from the first design was we are going to make sure WD, CC.WD is now pointing to this particular weather data subjects, right? At the same time, you want to make sure now in the new observer design, you want to establish the bidirectional link. You want to make sure you're also adding for subject observers. So this one is also pointing to this particular current condition observer. Okay, so after this, what do we achieve? What we have achieved goes like this. You can say cc dot weather data, right, is pointing to sub. What we're saying is cc.wd is really pointing to the sub. Okay, that's the first link. And the second link goes like this. We also say sub dot observers. Okay, it's a list. Let's say it's a linear. Linear structure at position 1. Okay, and now this one here is going to point to cc. Okay, equal to, right? That expression there will be equal to cc. So this is what it means. So that means sub at observer, and then at position 1 is now pointing to the same current condition object, right? There's a bidirectional link. So this is how we can establish the bidirectional link just for one single observer. But of course, at the runtime in general, you can have as many observers as you like for particular subjects. Okay. So now let's go over a little bit of code and then we'll trace it. Okay. Let me go back to here and then go back to observer pattern. And then observer is actually meant for building one-to-many. You can see we have one single subject over here, and many will be we can have as many observers as we wish. Doesn't matter how many, can be as many as you like because it's simply just a list or array. Okay, and then observers are attached to a subject. Okay, just basically some terminology you want to get used to. Right, we say attached to a subject or publisher. Sometimes we say observer pattern, and sometimes we say publish subscribe pattern as well. Okay, so and every time a subject will notify its attached observer about changes. So you want to go over the array, we'll go over the list and call the updates upon them. Okay, and then we sometimes we say subscribe, we say attach, we also say register, and also we say unsubscribe. You say also detach or register. Okay, so these are just the terms you want to get used to. But typically, I'll just either say attach, detach, or subscribe, unsubscribe. Okay, you can say other things, register, unregister. That's fine too. Okay, let's take a look quickly about the code. Okay, so the code itself is not that difficult. Okay, on the iPad, I'm just going to leave 2 clean pages for you, right? So you can actually see the architecture more clearly, whereas you can also see the code. Okay, but for now, let me just go over the code very quickly with you. Let's see for the subjects, right? It's gonna have a list of observers. And then we got, when you try to create a new subject, you will simply just try to create a let's say, empty linked list. And then you want to make sure initially there's no observer, right? You should know how to write this post condition here. So that means the number of observers should be 0. Or you can say observers that is empty will be true. Okay, and also attach and detach, right? That's also a very important operation over here, because you can think about attach and detach really correspond to when I say the first element of the observer should be CC, that's attach. On the other hand, when I say I don't really want this one to be CC anymore, so that'll be detach. Okay, depends on which way you want to go, and that should really just correspond to how you can insert and remove into a linked list, right? So now when you say attach, you want to make sure the observer is not yet in the observers list, right? You just say it's not there. Okay, that was easy. And also you want to make sure after that it should be there, right? I'll just leave out the do part for implementation for you. That should be quite easy to implement as a list operation or array operation. And then you can also do detach. You'll be exactly symmetric, right? Before you detach, you want to make sure the observer you want to detach is really there. Okay, so that's why has must be true. And also you want to ensure after detach, it's not detached anymore. Okay, so now it's not detached anymore. I think that there was a little bit typo over here. So now this should be not attached. Okay, I'll change the typo over here for the comments, because after detaching the observer, it should not be detached anymore. So there's a typo here. Okay, what about notify? Okay, I think this will be the very few lines I want to let you think about how you can implement it, right? I want to give you a little bit hints over here. If I go back to this particular diagram, right? That's the architecture diagram we have. You can also find a brand new one on the lectures page, right? Look at this. We are basically talking about how you can implement notify over here. Basically, we want to go over imagine that if the list is arbitrarily long, we want to go over all the subscribed observers one by one and try to update them. That's what we want to do. Okay, so how do we do that? Okay, overall, we simply just want to do, or actually already give you the solution, but that's okay. So we are simply say go across the observers as cursor. Okay, let me just say this. Okay, let's say let me just redraw this. You know what? Since we're gonna trace the code together, so I would suggest how about we simply just talk about the code quickly and then we'll trace it. That can be saving the time. Basically, the notify will just be, so now we want the update to be called on demand. So this is the time to demand. whenever we call notify from the subject, we're going to say go across all the observer, and for each one of them, I'm just saying across S. So cursor the item here will be of type observer. So I want to make a note for you. If you go to the code over here, what you really want to note is over here, across observers over here, and then as cursor, right? So now, so that means cursor the item over here is of static type observer, right? And also we know that observers is really a polymorphic array or list or collection, polymorphic list. So now, which means over here, observers 1 and also observers 2, for example, right? So these two different locations, statically, they are both observer, but dynamically, they might be different, right? Observers at position 1 and observers at position 2, they might be storing different objects dynamically. So now, when you try to call updates, so this is really where dynamic binding is going to shine. When you say dot updates over here, and also dot updates over here, right? So now I got two updates over here. So every time you call updates, dynamic binding is going to tell you that dynamic binding. So let me just finish this and then I'll answer your questions. So now dynamic binding simply tells you that, for example, if observer 1 has dynamic type, for example, current conditions, then you will call updates in current conditions class, right? That's dynamic binding. Okay, let me see the question. Do we use a remote procedure call every time we call observers.updates? Yes, we do. So now it's a very important point to note. In the case of observer pattern, there is still a need to really use remote procedure call. However, we are minimizing the number of remote procedure call we have to make. As we'll see in the tracing of the code, every time you will notify from the subject side only when necessary, which means we will only notify when there's really some change on the measure. In that case, it will be necessary for the observer to actually make the remote procedure call. Okay, so now let me just say this here. Remote procedure call is still necessary when notify is called on each observer. It is still necessary, but it's necessary. Okay, it's a really important point to note. Okay, so that's about the subjects. Let's take a look at the clients, I mean the observer. Okay, and then we'll do one exercise to let you see how to write a code. Let's say we talk about weather data. It's simply just subject. Oh, excuse me. Notice one thing. The subject class over here, we don't have. I think I meant to put the subject class over here should be. Oh, it doesn't matter. Okay. Weather data here simply inherits from subjects. Okay, and then you can rename the make as a make subject. Right, just a little bit showing you the feature for how you can do it in iPhone. You don't really have to rename if you don't find it necessary. And then for the weather data, you got temperature, humidity, and pressure, and also correct limits, the same as before. And then in order to make a new, weather data, you will call make subjects. And what the make subject will do is it is going to, let me just show you. The make subject here, comes from the make from the superclass in subjects. And the make over here is just going to create a brand new list, like an empty list of the observers. That's what you will do. We can reuse the code from the parent class. Okay, so you just say make subject, which will initialize empty observers. And then after that, you can set a measurement to whatever initial value should be. Okay, so that's about the subject side, which is not difficult. All you need to understand is about how the polymorphism and also dynamic binding works for the notify feature over here. That's the most important part for the subject side. Let's take a look at the client side. Okay, the main thing I want you to think about is how we establish the link over here. We know that in order to attach a particular observer, that's the link we have to build. But now, how do we actually establish this particular link? That's the question. Especially want to say, you want to establish this backward link when you try to create a new observer. Okay, let me show you the context, and then I will ask you how to write out one line of code. Let's go to observer over here. For observer, okay, and again, so these are the deferred features that will be subject to the implementation in the descending classes, right? So this one is not tricky. Okay, what about, let's say just do one of them, forecast. Okay, let's say for the forecast is going to inherit from, okay, don't forget we got this architecture here. We talk about forecast, right? Forecast inherits from observer over here. And then we got the make, and then we'll simply try to create we try to link the weather data, right? So now, guys, question for you. Remember from the first design, we'll simply say weather data is assigned to a weather data, right? Weather data is defined as one of the attributes for forecast, let's say, right? That's what we learned from the first design. And then that should be assigned to a weather data. But now the question is, how do we establish? So now that one there is going to say, this one here is now going to point to the weather data, right? So now we're talking about from this observer's perspective, right? We want to build bi-directional link. So one thing is we can see this one here is established by cc.wd is simply assigned to the weather data, right? Let's say, let me just change the name. Let's say this is WD, right? So this is the first line. Okay, hopefully you can see that. So now the question for you is how we can at the same time establish this particular link. How can we do that? Can we just do it in one line? And my hints for you, look at the architecture diagram. Is there any feature we can call from either the observer or the subjects to build this bi-directional link? That's my question. Anyone? What line should I write over here? Just one line. To really add this particular current condition over here into the list over here. Okay, this is really the, I would say that it's not really tricky, right? You just have to know what you're really trying to achieve and then try to implement that. Anybody? No one? How about something like this? Let me help you a little bit here. What you might think about is something like WD over here is this particular weather data, right? If I say WD.observers as a list, right? Now maybe I simply want to add CC, the current one, into the end. I can say maybe extend, and then I can put CC over here. Conceptually, that will work, right? Because I'm saying that since I'm trying to add CC the weather data to be WD. So symmetrically, WD the observer should be extended with CC over here for this particular example. However, if I go back to this particular line of code here, there is no CC because now I'm in a general class over here. So there's no concrete objects. There's only the current objects I can talk about. So now how can I do it? And also, I already got some feature defined for me over here, so I don't necessarily have to touch the observers directly. And the hints would be, you can look at the architecture over here, right? If you look at the architecture over here, there's got to be some features you can call that we previously talked about in the subject side. How do you add an observer into the list of observers for the subjects? How do you do that, right? Okay, anybody? If no, then I'm going to tell you the answer. Okay, John, good. Attach. So you're saying that we're going to call the attach over here, right? Okay, that's pretty good. Okay, exactly. So now, rather than having this thing over here, we're going to say WD dot attach CC. Okay, still CC over here is actually not a general solution to this. So what we'll do is current. Okay, guys, you can see this is the second time we are seeing using the current in the design pattern explicitly. Remember the last time we saw this was in the visitor pattern, right? Back on Wednesday. Okay, just remember you can definitely use the current like how you use this in Java, right? Okay, so these are the two lines that's really important for you to realize. This is how you build the bidirectional links, between the observer and the subjects. Okay, and then after that, you can make sure they're actually bidirectional, right? So weather data should be pointing to that particular weather data, and also that weather data, the observer that has current, that should be part of it, right? The current observer. Okay, so that's about it. Okay, and then as to how you define the up-to-dates, you can see for this particular forecast, we only worry about pressure. So that's why you will say current pressure is equal to weather data the pressure. And notice that for this particular contracts, we are really making some remote procedure call, right? But this will be necessary because we want to make sure it's really up to date. So that will be okay. And then for the updates, you can also look at the code. And this one here will be the same as how we did it previously. And then for the display, we don't have to do the updates anymore. Notice that when you look at the code for the second design for the observer pattern, for every time when you display, you don't have to make a remote procedure call explicitly anymore, like in the first design, because now we are guaranteed every time if there was a need to get up to dates, subjects will actually notify us, so we don't have to worry about. Okay. Okay, and you can go over the other two observers, like current conditions. Okay, very similar. You can see especially how we build the bidirectional link. Very similar. And also how we can keep things up to date. Similar. And also we got statistics as well. Okay. Any questions until now? And the next step would be to trace the observer pattern in detail. And then we are done for the second design. We haven't got to the third one yet. I'm not too sure if I really can get there in full details, but it is what it is. Well, I'll rather not rush. Hey guys, any questions so far about the observers? Okay, hopefully it's not really confusing to you because observer, I would say compared with visitor, it's not that complicated, right? Okay, so finally, I would like to trace the code, right? I try to set up the code in a very similar way as before in the first design. But now we want to see, are we now, oh, actually you can think about the code here is almost exactly the same as in the first design, how we can test it. But now, remember before we say, this line here, CC the display, the first time we call display would be efficient, would be necessary in the first design. But the second one would not be necessary because in the first design, you always have to call the updates, which will trigger remote procedure call every time. So that might cause some inefficiency. But now, if we move on to the observer pattern, right now, it may not be the case anymore. It's always efficient. Let's see why. Okay, I'm going to switch to iPad over here, and then let's see how we can trace it, right? Basically, I really want you to see, to visualize what's really happening for the observer pattern at the runtime. Okay, let's see. Again, we're going to see this. First of all, let's see. The code is really almost the same as before, so it should be quite familiar to you. Okay, so let's say, first of all, we create a new weather data here, and then 9, 75, and 25. 9, 75, and 25. And then I'm going to trace one of the observer creation in detail with you, and the other two are just done in a similar way. Let's say we do current conditions. Okay, let's say cc.make and then wd, right? Very similar to the first design. However, we want to build a bidirectional link. So now you can see the context object is cc and the argument is wd. So now we're calling cc is actually from current conditions. So we go to current conditions over here, and then we try to call the make. And then, so now the argument here should just be wd, right? So now A where the data will just be WD. And also over here, also where the data would just be, okay, let me do it this way. Let me just copy the two lines over here. You can see where the data over here is referring to the CC.weather data, right? It's the current objects. So we are really, it boils down into CC.weather data is assigned to WD, right? WD is over here, the weather data we are trying to attach. And also the next line is, after this, we're going to say CC.weather data, right? You can see it's the same weather data. CC.weather data dot attach. And now what's current over here, right? So hopefully you can see this. So this is nothing new. If you know about OOP in Java, if I simply put this over here, you would know what this really means. It would be the context object over here, CC. So current would just be CC. So now how do we execute these two lines? So now CC, the first one, CC.weather data is assigned to WD. So this is building this particular link, right? This link over here. And then we say CC.weather data. So now it's now referring to this particular, okay, CC.weather data here. So CC.weather data is now referring to this particular object, and we're calling attach CC, right, itself. So now what that will do is it's now going to make sure it, well, just grow the list one by one. So now list at position 1, 2, and 3. Position 1 is now going to point to this particular current conditions objects. Okay, any question about the first line? You can see this line here is the way from the clients, how the client uses it is very is just the same as before in the first design. But what really happens under the hood at the runtime is different, right? Because we are now trying to build a bi-directional link. Any question about this particular call? Okay, so now if you go on, let's try to do forecast. If you do forecast over here, WD and FD, so you'll be very similar. So I'm not going to trace in detail. So now that means where the data is now going to point to the same WD and also WD at position 2, right? Grow the list. So now that one there is now going to point to this particular forecast bi-directional link, right? Hopefully you can still see how the arrows go, right? Hopefully it's not too messy for you. And then finally, we're going to do for statistics, right? And also WD and SD. SD is over here. So now what we'll do is weather data should now point to this particular weather data objects. And then, so now we go to position 3. And position 3 should now point to this particular statistics objects. So now we got 3 pairs of bi-directional links. So far, we have achieved this particular line with 3 different commands to set up the observer and observer and also subjects. Okay, so now let's do the following. If we try to say WD that set measurement to be 15, 60, and 30.4. So now change this to 15, change this to 60, and change this to 30.4. And now, whether to update individual observer is completely up to the subjects, completely up to them. Okay, so now we'll say WD.notify over here. So this is, well, it's kind of up to your implementation decision. You might decide to include notify as part of the set measurements if you wish. But for now, I just want to make it explicit for you. Okay, so now WD.notify, what that will do is, according to what we said before, you're going to go over every of the observer you have linked to and also try to call their updates, right? Okay, hopefully you can see that. So now let me just show you very quickly. So now the notify over here, okay, the notify over here will basically go for across WD.observers. We'll go over this particular list one by one. Is observer, right? Each one of these observer, and then you will say loop observer dot updates, right? We have gone through this particular code already, and the update according to dynamic binding is you're going to see which dynamic type I'm calling. So now let's see very quickly. Okay, so now that would mean for the very first iteration, so now the observer is now referring to current conditions. So that means the update is going to call the version on current condition. And to update the current condition is going to update, I believe, the maybe the temperature. I forgot. Yeah, exactly, temperature. And then when you run the second iteration, so now go to the second observer for over here. So now that one there is going to link to forecast. And that one there is going to make sure the updates will call the version in forecast. And finally, the third iteration is now going to, index 3 is going to refer to statistics. And that one there is going to call the updates in statistics, right? Dynamic binding, gonna call one by one. You can see for each one of them, you're simply going to update them on demand. So now, if you try to go to the next line, for example here. So now when you say cc.display, fd.display, and sd.display, over here you can see for every of the display, I don't have the code over here, but you can see for the display in every of the app, you don't really have to call update anymore because you only call updates when you are being notified. So now these are no updates invoked. So it will be efficient. Similarly, when you go to the next one, if we call cc.display again, right, and also no updates will be invoked. So that will be the improvement we have made from the first design. So now you can call display as frequently as you like, but now every time you call the display, it's only going to use the local copy of the measures in the apps. But in that case, you don't have to worry about any inconsistency because the notify is really the key to make everything work. The notify here. So every time, if there's any change on the measurement on the subject side, they will call notified to make sure every observer can receive it. Okay. Do we require additional remote procedure calls inside of an observer's update feature to get information from the subjects? So yes. So in the observer pattern, let me just show you very quickly. In the let me see if I got it here. Okay, let me show you very quickly. Let's say here. In the observer class, let me just take one of them as an example. Let's say forecast. For the forecast, now in the updates over here, okay, you still have to say, for example, weather data, okay, weather data dot, let's say pressure, okay? You still have to really retrieve this particular value, the WD, the pressure. So this would be a remote procedure call. That is still required. However, as I said before, in the case of the observer pattern, you will only call updates not from the forecast side. It will only be called on demand. So which means the subjects over here for the weather data, you will only try to notify when necessary. So do I have, okay, notify here. So this will call updates on each observer when necessary. Okay, it will only be called when necessary. Yep, so apparently each observer might care about different parts of their updates. So I would say you can try to be a little bit more fine-grained when you actually try to develop your update feature. So let me put it, okay, let me make my point more precise. If you think about the update feature over here, for the forecast, you have to define your updates. For the current condition, you also have to define your updates. For the statistics, you also have to define your updates. However, each of the updates in different observer would be defined differently, right? Because over here, for the forecast, you only worry about pressure. For the current condition, you only worry about humidity and also temperature. And for statistics, you only worry about temperature. So you will have to define the update feature accordingly. Okay, if that's what you meant. Okay, guys, any question about the observer pattern? Right? I think it's quite a detailed walkthrough, but you will have to really try to review this particular page to really see how everything works together, especially how the number one. So when you review the observer pattern, two things you want to make sure that's really crystal clear to you. Number one, bi-directional link. Bi-directional links between observer and subject, number one, right? And number two, notify on demand. Okay, and of course, notify is actually called from the subject side. So these are the 2 points you want to make sure you review properly. That's for the observer pattern. Okay. Okay. Any question about the observer pattern? Any questions? Okay. So now my original plan was to actually also to go on to the event-driven pattern, to really talk about the flaw for the observer pattern and move on to the third one. Apparently, I only got about 10 minutes left. I don't think I can cover anything in detail for that event-driven design. I'll let you know what my decision is. Either I have to skip this part for my lecture, or maybe I need to cover that quickly, maybe next week. We'll see. Because we still got the program verification to actually cover for the course. That'll be the last part. That one cannot be rushed. Anyway, so I would say do you have any questions about the 2 designs we talked about today? Observer versus non-observer. Any questions? I'm not too sure about what your question is for notified for the from the subjects. So let's see this. If you look at this diagram over here, right? So now let's say, for example, let's say we already built a bidirectional link. So now when you say wd.notify, what that would do is it's going to go over all the observers for wd one by one, for example, the first one. And then it will simply call wd.observers at position 1, and then the updates. And this update is actually going to call the updates on current conditions specifically, right? Dynamic binding. So that's why we'll make sure current conditions will follow this particular link to actually call the updates to retrieve whatever that matters for current conditions. In this case, it would be humidity and also temperature. Okay, if that answers your questions. All right, so if no further questions, I will stop here, and then we'll still resume our normal lectures on Monday, and then I will have to see how we can finish the rest. Okay, either we have to give another extra lectures, I don't know, or I have to refer you to maybe some previous recording for event-driven design, or I don't know. I'll let you know maybe next week. But I think the bottom line is you want to review the observer pattern motivating problem and also the observer design pattern implementation. The source code is on the lectures page. You can also take a look. Okay. Any questions about what we covered today? Okay. If no, thank you for coming, and then I will see you next week.